I chose the article Angling for Students Mathematical Agency. It focuses on a group of fourth graders from Columbia and is also one of my target topics of geometry. The article starts out with a group of students measuring the angles of a triangle. Emily uses her protractor to measure the first angle, and she tells her group that the angle is 130 degrees. Her teacher then asks her how she would classify that angle. She says that it's an acute angle. Then her other group members ask her how can it be an acute angle if it measures at 150 degrees. That's when Emily insisted that the protractor was lying. Instead of reteaching or explaining to her why she might be wrong, the teacher encouraged her to explain why she thought the protractor was lying. This is letting the student be proactive in her own learning. The teacher also asked the students why they thought the protractor might be confusing. Some of their answers were that there were too many numbers and that they didn't understand the two different sets of numbers. That's when, in the lesson, the teacher gave them the chance to design their own protractors. Here are figure 2 and figure 3 are two examples. Miguel's is figure 2, and he only wanted one set of numbers on his protractor. His protractor also had two adjustable hands that could move while you were measuring the angle. This activity shows an example of, instead of the students relying on what seemed to be procedural knowledge or what they already knew about how to use a protractor, the students drew on their conceptual understanding about angles. In the article's example, the students were not relying on the teacher or the textbook. They were relying on the protractor. A couple of key points that stood out to me in the article were that the students' awareness of their knowledge supports the development of a sense of being authors instead of only users of their mathematical knowledge. And that's a good example of what figure 2 and figure 3 are, of them being their own authors. Another point was that students who can express their mathematical agency can rely on their own thinking and their cooperation with others to expand their understanding. And a good example of this in the article was when Miguel and Juan disagreed with Emily at the beginning, saying, how can it be an acute angle if it's 130 degrees? At the end of the article here, it says that this was used for a small group, but that they encourage teachers to try this with a whole class, where students can refine a protractor or other math tools, justifying on the basis of their understandings. Using protractors is always hard for some of my students, so when we get to this lesson, I will definitely keep this article in mind.